Welcome back. So we're going to start talking about zeros, multiplicity, crossing, and touching. What's that all mean? Okay, well, let's take a look just at, let's imagine a lot of our polynomials that we're going to deal with right now, they're already going to be factored, okay? We're not going to deal with factoring them until the next section. Okay, so in 2.3, we're going to assume everything's factored. That's nice. But let's start with a very simple one. By simple, let's say y equals x minus 2. Okay. Now, I'm going to draw parentheses around this and a 1. We don't really need them, but I want to sort of showcase what's going on. So if I were to graph this, we should all know what's going to happen. It's going to cross the axis right like so. Now, what I want us to notice is that before the value x equals 2, before the value of the x equals 2, y is going to be negative here. Okay, it's below the axis. And after the line x equals 2, the y value is positive. Okay, so that's what I want us to sort of be taking away from this situation right here. So y is less than 0. Y is bigger than 0. Okay, so what has happened? This graph or this equation has crossed the axis at x equals 2. Okay, and the language I'll use is I'll say it goes from negative to positive. I should say goes from being negative to being positive. Okay. All right, let's do another one just to sort of get ourselves on the same language page. Y equals, well, let's do x minus 2 cubed. Okay. So if I have y equals x minus 2 cubed, that's actually going to do a lot of the same thing. Okay, so I'm going to go over here to 2. And it's going to be a cubic graph. So it's going to look like so. Let me smooth that out a little bit. Okay. Again, same things happening in that. After the line x equals 2, the graph is positive. Before the line x equals 2, the graph is negative. The same thing's going to happen no matter what if I have an even or an odd power there. So they all have the same behavior here. Okay, and when I say they all have the same behavior, what I'm referring to is crosses the axis at x equals 2, and it goes from being negative to being positive. All right? Now, these numbers here, the 5, the 7, in this case the 3, in this case the 1, we call those the multiplicity of the zeros. So all of these have odd multiplicity. Okay, so x minus a to the n gives a 0 or a root at x equals a of multiplicity n. All right. Now, we've looked and we see how odd multiplicities affect the game. Let's see how even multiplicities affect the game. Now, generally, we don't worry about 0, okay? That doesn't come into play. But n equals 2, n equals 4 will. So let's take a look at y equals x minus 2 squared. Okay, so we're going to move to the right by 2, and we're going to have a polynomial, or I'm sorry, a parabola there. Okay, and you sort of again probably guess that x minus 2 to the 4th, x minus 2 to the 6th, those are going to have similar behaviors at the roots. Okay, and what happens? Well, at x equals 2, it's positive and then it stays positive, right? Okay, positive, then it stays positive. Okay, so here we have, let's see, it bounces at x equals 2, or just touches, we might say. I like bounces, but I think touches is the term that they use. Okay, and it stays positive, so it's positive on both sides of x equals 2. Okay. All right. So that's it for this one. We'll put this together and we'll get some nice graphs next.